Welcome to Computer Science 50. This is the start and end of week 10. Allow me to introduce your head teaching fellow, Jansu.
Thanks. I just have a few announcements to make. I don't know if this will still make you. Oh, I just have a few announcements to make. I don't know if it will make you happy, but we won't be having office hours from Wednesday to Sunday, but tonight we'll be having a very nice super section with Kato, who also deserves a round of applause. He'll be covering JavaScript more extensively, and he'll have his regular walkthroughs tomorrow, 4:30 to 6. Location to be announced and posted on the website soon. And please remember to RSVP for the seminars for the final projects. You guys all have submitted your perfect pre-proposals. We're all excited, but we want to help you in the best way we can. So that's why it's very important that you guys RSVP. So thank you.
All right, thank you. All right. So we, of course, have been focusing on web-related development these past 2 weeks, and I thought, what better way to begin than a look at our own website. Our own Drew, of course, continues to blow away all previous records. Actually, only a moment ago, I think he was at $1.4 billion. It seems to have dropped a little bit. It's down to $1.2 billion. And every 3 or 4 days, I've been going in and editing our own XHTML to increase the width of this table because it keeps starting to wrap. We did not envision 12 million% net gains when we defined that column's width. So congrats to him. And keep up the good work to Daniel, Samuel, and John. Who are at 100% loss. Sammy, though, is hanging in there barely. Also, I thought we would motivate today by pointing out one of my favorite websites, getting increasingly topical. This is a website devoted solely to the purpose of answering the question, is it Christmas? ? We showed this last year, and sure enough, I got an email on December 25th, hey, David, check out this URL. And sure enough, one day a year, this thing actually changes to say yes. There's another one, which is a few months dated, perhaps, but this domain name was apparently available. Has the Large Hadron Collider destroyed the world yet? You may recall that controversy. This also continues to function so long as that is the case as well. So check those out if you would like on the course's website. Today we begin to look at a few things. The first, though, is a bit of a congratulatory note. If I can turn this on for just a moment, switch us over to our document camera here, and award 2 of our amazing prizes for Problem Set 5. So you'll recall that Problem Set 5 tasked you all with conducting a scavenger hunt. Some of you really threw yourselves into these. Some of you never left your dorm rooms. But to those groups that did go out and find some of these photographs, congrats to 2 sections in particular who submitted this Google map to us containing the locations and photographs that they did in fact find. So if you'd like to play around with this later, it's under Lectures, under Scavenger Hunt, and I can though, BC, our runner-up submitted this map here. Rather appropriate given our current focus on Google Maps. Each of those little markers represents a photograph found. And allow me to call up a representative of Vivek's section who submitted and will now receive. We can zoom out here. I made this on my computer. Congratulations to Vivek's section as the runner-up for having found almost all of the photos. If we could, a round of applause. I think it's only appropriate. Sammy, are you here? We can sort of offset the pain of Sammy. Come on down. So we have $1 in this for you. We, of course, promised an amazing prize. Congratulations. Thank you very much. So your prize will be amazing ice cream for you and your section. The winner, though, submitted this map instead. So you'll notice perhaps a pattern here. There were, a few dozen photos that we tasked folks with finding. I know I learned slowly. We have this submission for the winner, and you'll notice, of course, that the key to winning this thing, apparently, and finding as many photos as possible, was to, once we zoom out here, The key was, of course, to actually cross the river where the remainder of them were. So this, our congratulations now go out to Daniel Carroll's section. I made this as well for him for finding the most photos. So congrats to Daniel's section as well. You really don't care, do you? Nina, one of their representatives here today, who took many of these photos. If you'd like to claim your amazing prize, come on up. So feel free to check out where all these photos are. Congratulations to you as well.
And Colin.
Oh, and it's Colin. Colin, where's Colin?
And Rachel's right next to him.
Okay, and Rachel's right next to him as well. Congrats to all three of these guys. Okay, thank you. Wow, what a pathetic round of applause today. All right. But we are quite proud of you all, so we will continue to exhibit those on the course's website. All right, so let's dive in. I know. Third time's a charm. Let's dive into some of today's look at Ajax and then ultimate compilation. So we're going to come full circle today. So we're going to conclude our look at web-oriented software development, looking at some neat things you can do with Ajax and in turn Google Maps. And then we're going to take a step back after our break and ask, all right, well, what in fact has been happening from the ground floor up since week 1 of this course when we introduced C? We've been taking for granted that there's compilers, that there's interpreters out there, but how in fact is this process of actually running code working? And in turn, where can you go from here after CS50? And we'll hint at where you go in CS51, 61, and other courses still. So let me go ahead and pull up the following examples. I went ahead and built on some of our examples from last time that were involving stock quotes. So among our samples today, which you do have printouts are a continuation. This is Ajax 4.html. So terribly simple. Didn't put much effort into the aesthetics here, but recall last week when you typed a symbol into this field, we actually got back a stock quote. This time, though, when I type, say, Yahoo symbol, I'm still going to get back some piece of information embedded in the web page, but I decided to take things up a notch. Last time, recall, I only supported getting single quotes for Yahoo or Google. But this time I decided, you know, it'd be neat if the user actually provides a comma-separated list of symbols. Let me see if I can't go ahead and get multiple symbols. So in and of itself, not all that amazing. I've simply embedded some boldfacing and some HTML text there. But what's actually going on behind the scenes? Well, let's use one of our favorite little tools, this live HTTP headers. Let me go ahead and redo this. Get quotes, and take a look now at the return value that comes back. And notice that one of the URLs that was accessed behind the scenes was in fact this one. So behind the scenes, just to zoom in on this, I apparently made a quote to a file called quote3.php and then passed in an HTTP parameter called symbols and then gave it a comma-separated list of variables. What's this %20 though all about? All right, so it's just the URL encoding of a space character. So let's take a look for just a moment now at quote3.php and see what this thing is in fact returning. So it's very similar to last time, but I decided to add a couple of features. So one of the first things I decided to do here was at least tolerate a bit of messiness from the user. So it's rather annoying, I would say, when you go to a website and your input gets rejected because you didn't put the slash between the expiration month and year of your credit card, because you didn't put your phone number in exactly the prescribed format that the programmer wanted you to, because these are not hard problems for a computer to solve, to sort of massage, so to speak, the data into something a little more computer friendly. So the first thing I decided to do was massage the input into CSV, comma-separated variables, or values, which is something we looked at in problem set 7, and I somewhat carefully decided, you know what I'm going to do? I'm going to allow a user to type in either a comma-separated list or, as is also common, especially on websites that support tagging and this kind of input, spaces as well. So I had to think through a piece of logic. How do I support this? Well, you know what? I decided to do this. Let me go ahead and replace, using the stir replace PHP function, any commas with just a single space. That is, let me allow the user to type in commas, but if they're there, blow them away, but replace them with some known character, like a space. Then I go ahead and decide to do stir to upper, so capitalize those strings just arbitrarily. I wanted to keep everything neat and force everything to uppercase, even though it's not wholly necessary. And then there's this function, preg split. You may recall using preg match, either in lecture examples or in your own problem set 7, and this supported regular expressions, Perl syntax for regular expressions, which was very powerful for validating data. Well, you can also use it to match on characters in strings, but then split them up based on those patterns. So you can take a long string that just so happens to be separated by spaces and transform that thing into an array, where each of the actual words is now a member of the array. So this thing is just saying what? Split the string called symbols based on this regular expression. What is this regular expression? \s plus representing. So space. So if you look through the little cheat sheet for most any regular expression manual or in PHP's manual online, you'll see that \s represents white space, the space bar, the return key, a tab character, whatever, and the plus just means one or more instance of this. So what this third line of code does for me is it stores in symbols an array this time, not a string, containing all, in this case, 3 of the symbols that I typed in. And then this is a neat feature too. What I'm going to go ahead and do is implode that array, which means take the array and implode it into a string again, but this time the string is apparently just separated by commas. So I seem to have done some work and then undone some work, but this was so that I could tolerate messy input from the user, like Yahoo, space, 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 Goog, comma, MSFT. And that might be a little arbitrary, but with these 4 lines of code, can I handle that kind of input? So this is meant to suggest how you can actually write fairly tolerant code when you're interacting with users. But here's the interesting thing today. I'm really taking to heart this idea of Ajax. Ajax, again, used to stand for Asynchronous JavaScript and XML. That was the acronym. But these days it's evolved into something less XML specific. You can use something called JSON. You can use XHTML as your return format. But today we're going to look at a use of XML. And you'll see how this is helpful perhaps in problem set 8. So what I decided to do this time is first tell the browser that what it's about to receive is not text/HTML, which is the default MIME type, so to speak. It just means, hey, browser, here comes a web page. Now I want to explicitly tell the browser, here comes some XML. And the XML that I'm actually going to send to the user is generated by these lines of code here. So you know what? Let's take a look. I had my little sniffer here. This was the URL that got pulled up, this update quote3.php. Let me go ahead in a separate window actually get that web page and hit enter. Well, apparently what's being returned from my own quote3.php script is this. So this is an example of XML. We've talked about this briefly. XML is pretty much like XHTML or HTML, except the tags are invented by you. You don't need head, you don't need body, there is no boldface, italics. XML is really a generalization of this stuff called XHTML, whereby you get to define the tag names, you get to define the attributes, and you do this so that you have sort of a way of marking up your data. So you have a way of tagging your data literally so that when you're processing it on a computer side, like with some JavaScript code, you can pluck out the relevant pieces of data. Now, we kept things simple last week. Last week, I instead had my quote2 and quote1.php just return some raw text, just some raw XHTML, and then I plug that into the page. But now that I want to actually return interesting and different pieces of data, not just one big blob of pre-processed markup, well, now I want to be able to tease apart, well, what's the quote? What's the symbol? What's the name for that symbol? What's the price? What's the high, the low? In other words, if you want to maintain metadata, much like you would in a spreadsheet or some other file format, XML is a wonderfully useful way to go. It's expensive space-wise, because there's a whole lot of purple stuff up here that's just metadata. It's not actually useful. It's actually not data. It's just there to hint at what's inside this file. But we're going to make use of this nonetheless. So this code now in quote3.php, just these few lines of code, has the result of generating this XML. And this is precisely what you'll want to do in problem set 8 when it comes to generating news and links to articles. So what am I doing? Well, I'm calling fopen using that same URL we've been using for days for Yahoo Finance. I'm passing in a symbol of $ symbol, even though it's wrapping. And then I grabbed from problem set 7's long laundry list of format strings, SN for stock symbol and name, and then L1 for the last price, the high, the low. I just looked up what symbols I want. Now I have a loop, much like you might have used in other contexts, or certainly will in problem set 8. I have a loop that's going to call fgetCSV, which just iterates over a CSV file and grabs row by row, but it returns the row as an array. So I can get at individual fields, much like I could cells in Microsoft Excel. So what am I going to do with each of those fields? Well, for each row in this CSV file, which to be clear is going to look like this. Let's also do an example with this. Let me go back to my browser, open up a third tab, and type in 4 symbols, something like Yahoo, Goog, MSFT. So now I'm simulating with my browser exactly what the PHP code is doing. Notice that as it did last week, it pops up a CSV file, and if you have Excel or any old text editor, you'll see a little database. So the goal of this PHP code is just to iterate over this stuff. So that's exactly what I do. So the first thing I do is I output open bracket quote symbol equals quote unquote what? Well, the 0th cell. So the first column, which again represents the symbol. Then I output the name in between quotes, and that corresponds to Yahoo and Google and so forth. But notice this. Why do you think I included HTML entities here? Anyone know what that function does? Yeah. Yeah, it escapes characters that have special meaning. In fact, it was very easy this morning when to break the first implementation of my code, because rather than type in Yahoo or Google symbols, you know what? I tried to pick a corner case like AT&T. Now, AT&T's symbol is just ATT, but the name of AT&T is generally written as AT ampersand T, but ampersands, recall, have special meaning. They demark the start of an entity, which means it's a special symbol that you may be familiar with from looking at XHTML. Well, bad things happen if you're trying to get data like that, which actually contains an ampersand. So HTML entities rewrites something like that as what? What does, if you're familiar, an ampersand get rewritten as? So ampersand becomes, when you escape it, so to speak, it's annoying and it's kind of silly looking, but that. So in XHTML, to avoid parsing errors, any ampersand has to be written as ampersand AMP semicolon. And this includes actually pasting in URLs from websites. If you embed a Google map in your web page and you don't escape any of the ampersands that are in the get string, which again are used to separate parameters, like foo and bar and baz, well, if you don't do that, the page will be deemed invalid. So if you try using the W3C's validator, as some of you did for problem set 7, and you were told your page is invalid, even though you were very careful with that stuff, well, it might just be because you've embedded an ampersand. So FYI with that. But now back to the code. What's it doing for us? Well, we're outputting open bracket symbol, quote, symbol name. Then inside of that, I'm outputting the data, I'm outputting the high, and I'm outputting the low. And the end result, of course, is something that looks like this. But everything's nicely formed. It's nicely indented. It's nicely symmetrical, which is nice because now I can parse this programmatically on the JavaScript side. So to summarize, I went to this page. I typed in a string like Yahoo, Goog. I hit get quote. My browser made a request to quote 3.php. That PHP file generated XML and sent it back to the browser. And now my browser has somehow taken that XML and transformed it into this XHTML with some bold facing and some line breaks and some dollar signs prefixed to those numbers. So let's see how that's working. So let's take a look in Ajax 4.html. Fortunately, the stuff down here is very simple. So this is the XHTML, which is pretty much identical to what we did last week. Notice I did do one thing differently. On submission of this form, I'm apparently calling a function called quote. But what does this do for me? What is this string here doing? What does this represent? So this refers to what in this context? Yeah, so the form element. So this is whatever element you're currently in. This dot symbols means, okay, that's the input field that has a name of symbols, and its value, of course, is whatever the user happens to type in to that box. So I'm calling this function. Now I need to actually see what's going on in this code. So let me go ahead actually and shrink our font a little bit so that we can fit more of it on the screen here. Well, that's okay, actually. So let's go here. This is CS50.net, CS50. Okay, lectures, weeks 10, source. Yeah, Ajax 4, close this one. OK, much smaller, and I'll zoom in as needed. Too small? Too small? Too small. All right, try one more time, then we'll move on. All right, change this to 12, do 14, boldface, session. Makes it less boring if I murmur, right? All right, CS50, log into that. OK, lectures, weeks, 10, source. And here we go. Everybody's happy? OK, better. All right, so what's actually going on here? The function is called quote. It's being passed an argument called symbols. This stuff is copy-paste from last week. So these are the lines of the code that actually enable us to make an Ajax call. So apparently the interesting stuff has to be happening when the XML actually comes back. So how does this happen? Well, it's this line here, like last week, that we construct a URL that's of the prescribed form. Quote3.php, question mark, symbols equals something. Now we make the Ajax call. So we do this thing here, request.onReadyStateChange equals handler. Well, this is, quote unquote, registering an event handler. So what this is saying is when that Ajax call comes back, call the function whose name is handler. And again, Ajax is all about asynchronicity. So this means the browser is going to make an HTTP request and then just start twiddling its fingers and doing whatever else needs to get executed in code. But when that HTTP response comes back from the web server, whether it's in 10 milliseconds or even 30 seconds, this function called handler is going to get invoked so that you can do something with the response. We're using the get method according to this line here, and we're sending the request here. So what is the handler method actually doing for us? Well, all I'm doing with this handler method is generating some XHTML. So imagine or keep in mind that what has been returned to this function is a snippet of XML. So this function has effectively gotten as input this stuff, a big XML file, or small XML file. Now, what is it going to do with it? Well, I check a few things. So if the request's ready to receive this, this is copied and pasted from last week. 4 is the number demarking success. Well, if that's the case, I then check the status of this request. And why is 200 something I'm checking for? What does 200 represent? That's good, right? So 404 is bad, file not found. 401, bad, forbidden. 200, good. And you've probably never seen it because the browser does not tell you when something good happens, only when something bad happens. So here, I'm using now what are called DOM functions. So we talked briefly last week about the notion of a DOM, document object model. And this just had to do with XHTML and XML being essentially a tree in memory. Not so much a binary tree, but a tree with any number of children at any different point. So it turns out that with JavaScript come a whole bunch of functions, DOM functions, that allow you to traverse a tree. You get them for free. You don't have to implement pointer kind of manipulations. You can just call these functions. So the means by which I can get at the XML is as follows. Request.responseXML is the means by which this event handler, the function called handler, gets this. So it's not passed in as an argument per se. It's passed in as a property or data member of the original request variable. That XML fragment, because it's not text per se, it's actually been parsed. What response XML really is a DOM. It's a tree. So think of this like a pointer to a tree. Now, this tree has a bunch of methods, functions associated with it. And here's where we're hinting again at object-oriented programming. It's not just a data structure. It's a data structure that has functions associated with it. And one of those is called getElementsByTagName. So I appear to be calling on this DOM tree, this response XML, this method, getElementsByTagName, get all of the elements called quote. So what that's doing conceptually is it's looking at this XML file, and it's grabbing as an array every element, every tag called quote. So what's returned by this line of code is an array of size 3. That's it. It's giving me an array of nodes from the tree. Now what am I going to do? I'm going to iterate over these quotes. So quotes.length is just 3 in this case, because quotes is the array, length is the property. What am I doing here? Well, this is very C-like. I'm declaring a local variable and storing in it the ith quotes, just so I can talk about it without all the brackets. And now this looks a little messy, but it's just generation of XHTML. For each of these quotes, what I want to do is generate something that looks like this. So I apparently need to boldface the name, parenthesize the symbol, couple line breaks, then price colon price, high colon price, low colon price, and then do that in a loop some number of times, 2 in this case here. So what am I going to do? Well, here's my boldface tag. And I'm appending that to the XHTML string that I defined earlier just to be clear, as empty. So I initialize XHTML as a variable, which is an empty string. And then plus equals is the concatenation operator in JavaScript. It's like dot in PHP. So plus equals just adds to this empty string, open bracket B, close bracket. Then it appends to it, what's this? Well, quote. OK, so this is a node in the tree. So if I go back to the XML fragment, I'm iterating over this array. So what I'm currently looking at is this node in the tree, the quote node. All right, so quote dot get attribute. Get attribute is another DOM function that you get for free when you start manipulating DOM elements. And so this thing, as you might imagine, just returns the value of the attribute called name. So this method call here returns what string the first time through this loop? It returns the string, quote unquote, Yahoo Inc. Right? So this is an attribute, name, and I'm saying from this current quote element, get the attribute called name, and what that returns is whatever's in between quotes here. So that's where I get the Yahoo Inc. string from. That's why it gets printed out in boldface here. Because then I parenthesize, using parentheses here, what the symbol is using the same DOM method. Then I close boldface. Then I add a couple of line breaks. Then I simply say price, $, and now this is the only bit of trickery here. The only thing that's a little more than unclear on first glance. So let me pull it onto one line. Notice I'm appending to the XHTML variable price, $, and then this crazy long string. So quote is again the current node. So that's this thing, is what I'm iterating over, this thing that I've just highlighted. So that element has another method, not just get attribute, but get elements by tag name. We saw this before. What elements do I want to get? Well, you know what? I want to get all of the price elements, all of the price children, really. So get elements by tag name starts at this node in the tree and then goes through all of the descendants looking for nodes called price. Well, I generated this XHTML. I know that there's only going to be one price element. So take a guess as to why I immediately follow this method call, get elements by tag name, with open bracket, 0, close bracket. Because that method's returning what? It's returning an array. We used it before, right, to get the quote elements. It's returning an array. But I made this XML. I know there's only going to be one price element. So why don't I just get the 0th one in that array immediately? Sort of a leap of faith, but I've sort of planned things by having generated that XML myself. So what that returns is the 0th price element, which means I'm now, if I highlight it, talking about this node in the tree. Now, what do I want to get there? Well, even though it doesn't quite feel like a tree at this point, this is the node. It's called price. And anything in between its start tag and its end tag is, if you write it as a tree, as we did last week, is just a node beneath it. It's a text node. It's a string. So actually, this node called price has one child. And that child is the string, quote unquote, 9.89. So that's why I then say, OK, go to the 0th price element, grab its first child. So what the DOM functions give you, what DOM gives you is not only methods, but also properties. And you get a free property called first child. It's like a pointer to the very first child of this element. And then it turns out that every node in the tree has a value. So there's this oscillation here between the notion of like a node in the tree and then a string that's actually stored in that node or beneath that node. And so at each step here, each of these dots sort of represents a step deeper and deeper into the tree. Am I finally getting from the quote element down to the price element down to its actual value, which is 9.89. And that's why this is what's printed out after the $. Then I do a line break. Then I do the same thing again, but getting the high element. Same thing again, getting the low element. And so what's actually outputted to the page is this stuff. And unfortunately, if I go ahead and view source for this page, you'll notice that what I get back is the JavaScript code. So I'm not actually seeing this XHTML. There's no boldface word Yahoo. There's no boldface word Google, because these DOM methods are being executed not server side, but client side. So you can see the source by default, but not what the methods are actually doing. Because why does this XHTML actually end up in this web page? Well, after all this looping, the very last line in this program, in this function, is this. Document.getElementById, quote unquote quotes, inner HTML. And that's the trick we saw last week, because if you scroll down to my very minimal XHTML, notice that I left this little placeholder, seemingly useless. It's a division of the page. It's got an ID of quotes, but it's completely empty. There's nothing there at all. But that's why I'm putting inside of it, ultimately, that dynamically generated string of XHTML. So if I put up a little placeholder here, like a whole bunch of X's, and then reload this page, you'll actually see that what happens is, in fact, that inner HTML, Yahoo, what just happened? What did we break? Damn. Why is this broken? Yahoo. Wow. Okay. Reload. Hang on. AT&T is working. Goog. That's working. Wow. All right. One last try. Oh, wait. Okay. Goog. Oh, goo. Okay, apparently it didn't like some of the space I added, so let me, now that I've hopefully recovered, replace the X's, reload the page, goog, get quotes. Whew. Okay, recovered. All right, so there's some white space it wasn't liking. So that's all this thing is doing, but why is this actually going to help us? Well, think, if you've read already about problem set 8, just to motivate this, we have linked on the course's website this link to the staff's implementation of this mashup. And what you'll notice is this thing automatically populates the viewport, so the part of the screen you can see with markers, such that if you click on a marker, you actually see links to news, for instance, to Cambridge, Massachusetts. If we click over here, we'll get presumably Everett, Massachusetts. If we zoom into one of the few other zip codes I know, like 90210, enter, we'll now end up over here in California in the Beverly Hills area, and there's the news for Beverly Hills. So there's a lot of dynamism here, and we'll talk briefly about this, but this is what Cato will talk about tonight and tomorrow in the super section and walkthrough. These little bubbles, these cartoon bubbles, are somehow getting dynamically updated with XHTML. So the code with which the staff's implementation of this mashup is doing is pretty much taking a blank Google bubble called an info window and quickly whipping up some XHTML, just like I did, and then inserting that into the info window. So this kind of dynamism, this creation of XHTML on the fly, is actually quite useful. So let's take a look now at this example, Ajax5.html. So this file here is a little more useful than the first example. At least it's a little more insightful, because if we go back to our directory and choose this guy, I actually, for some testing purposes, decided to embed what I called there's only so many people who have access to this file. Interesting. And he'll be leading a super section tonight at 6 p.m. So here is a slight variant of our Ajax example. And all I did was added this stupid looking thing. So look at Ajax5.html. You do not hopefully have the rickrolled version in the printouts. Notice that what I added to my form was this thing, a text area, which you might not have used before, but it's like a really big text field, an input field. I gave it an ID of debugging. I said make it 80 columns wide, 11 rows tall, because what I'm going to do now in this code, which is almost identical to what we just looked at, is this line up here. So right before I do anything at all, I decided, you know what, it'd actually be useful for me to not have to keep alt-tabbing between all these different browser windows, simulating the CSV file stuff. I just want to see what the browser is getting. So what I actually have here in the document, get element by IDs, debugging fields, value, is, you know what, I'm going to take what's inside of that request and dump into it response text. So inside of this XML HTTP request object, you get a couple of things. One is a response XML, which is a tree that we've just been talking about. But then you also get a text form, a string form of that, which is the tree sort of flattened so that it's literally just a huge string that's whatever was returned by the server. So what this does for me is this. If I go ahead and type in goog and click Get Quotes, not only do I get the thing printing out down here, but again, for debugging purposes, I just dumped response text, which is what came from the server, just so I could see it, just so I could do a little sanity check as to what's going on. If I do this with two fields like Yahoo and Google, notice what I'll get back is not only the embedding in the page at the bottom of Google and Yahoo, but I also see the XML that came back. So hopefully just temporarily turning on this debugging window is making a little more clear what's going on here. Browser pulls up a static HTML page that's got some JavaScript. I type in Goog, I hit submit. That triggers an HTTP request back to the server, which does some stuff over with Yahoo, and it gets that data, massages it into XML, returns XML to the browser. That XML looks like this, and then I use these DOM methods to walk this tree, to walk this XML, and actually grab the fields I want and format it as XHTML down here at the bottom. Well, there's one other thing we want to show you, especially since it leads up to some really neat things with the Google API. So in Ajax6.html, you'll notice that it's pretty much the same code. So I'm going to skim over most of it. But there's one important thing to note. So we've said in Ajax 4, I pointed out this line here. So when I said get quotes, I did request.onReadyStateChange gets handler. So I said call this function called handler when your ready state changes. And I could have, to be clear, called this anything. I could call this function, albeit stylistically poorly, foo, and I could change the function's name to foo, and the same thing would actually happen. Well, it turns out I don't really need in JavaScript a whole separate function, because JavaScript supports what are called closures. So this is one fairly useful construct that I'll note here. So this is the same code, Ajax6.html, but I'm going to scroll down to that corresponding line, and whereas before I said request.onReadyStateChange gets function, or gets the function name, you know what? I'm going to skip the whole process of defining a separate function, because I don't really need a separate function if it only gets called by one line of code, right? It's not something I need to reuse per se, so I can inline, so to speak, the function's definition. So you'll see this a lot in JavaScript, as well as in Google's own documentation. What I'm doing here is I'm saying, yeah, assign a function to this event property, but don't bother giving it a name. Just say function, open paren, close paren, then a curly brace as usual, and just put the whole darn definition inside of this function. So you're sort of defining a function inside of a function by way of what's called a function closure. And for simplicity, just think of it, a closure, as being a function that's sort of closing in, and closing in it a whole bunch of statements and even some variables as well. And this is useful far beyond the scope of what we're demonstrating here with the stock example, but closures are something that will come up a lot in, say, CS51. A nameless function like this is otherwise known as a lambda function, if you've heard the term, but it's just very useful, and you'll see why in some of the Google examples, because what it lets you do, in fact, is access variables that are not, that were themselves local to another function. So let me try to state this one time clearly. Because I'm defining this closure, this lambda function, inside of another function, that function called quote, this is sort of like a backdoor. In C and in JavaScript and in PHP, we've always said that when you have a local variable, the only function that can access that local variable is the function in which you define the variable, right? This is sort of week one stuff. The exception to that is that if you use a lambda function, and if you define a closure inside of another function, this function can actually access any of the local variables from the function in which it itself is being defined. And you'll find this is not obviously useful at first, but this has wonderfully useful properties because it means you don't have to use global variables, and you can sort of bundle up inside. You can enclose in functions variables that are all actually local to other functions. So who cares is sort of the perpetual motivating question. Well, we will care when we talk after a 2-minute break about how you get from those simple examples to this kind of thing. Let's take that break. All right, we are back. So one of the most compelling features of Google's APIs for the course, frankly, is that they are just so accessible even to folks who haven't programmed in this language before. So Google Maps' API is entirely written in JavaScript, and it allows you to interface with a whole bunch of methods that Google themselves have defined. The means by which you can start embedding your own Google map in a web page is with this 4-step process. One, you sign up for what they call an API key. This is just a really big random number that uniquely identifies you and your website, and the problem set 8 spec walks you through the process of getting with your Gmail account or whatnot this easy key. You then will be walked through in the course's problem set through a number of the concepts behind this API as well as some examples. And in fact, what I did even to prepare some of today's lectures examples were follow some of these very tutorials. And one of the lessons you'll see in problem set 8 is that 1, we don't give you any code. 2, we don't really hold your hand through the coding aspect of things, but rather we point you toward this resource and this resource. We suggested what you should look at so as to bootstrap yourselves to figuring out something that you've never once, presumably, seen before. And this is all toward an end of letting you exit the course more empowered than you entered so that you can actually teach yourself these kinds of things come course's end. So the very first example I decided to whip up today is this one, map1.html, which you have a printout of as well. And this is literally copied and pasted from Google's own website. This number of these lines, so lines 1 through 38, is all it takes to embed a Google map in any old web page. Now, it's an underwhelming map, to be sure. This is all you get by embedding that snippet of code in your web page, just a rectangular box that's a few hundred pixels wide by a couple hundred tall, but it is in fact a clickable and draggable Google map. And the salient aspects that I should point out are this. 1, we have this script tag in the header that's very long, but notice that it's actually referencing a file on maps.google.com. So this is like a sharp include in a JavaScript context of someone else's API file, someone else's header file, but in this case JavaScript code. Then I have my own snippet of JavaScript. This tag here, the open tag script, says, hey browser, here comes some JavaScript. And all I do is define here a function called load. I'm apparently calling some function that someone else wrote, Google, that just checks, is this browser compatible, or is it something way old that just won't work, or something on, say, a cell phone that just won't work. But if it is compatible, declare a variable called map, instantiate an object, so to speak, of type gmap2, the Google Maps 2 API. And where do you want to plant this map? Well, let's plant it wherever there's an element in my own web page with an ID of map. And sure enough, the very small snippet of XHTML I have on this page is this one. Div ID equals map. Give it a size width of 500 pixels, a height of 300. And in fact, if I change something like that to be maybe 800 wide and 500 tall and then reload this page, you'll indeed see that now I have a slightly bigger map. Still underwhelming, but slightly bigger. So now let's take a look at map2.html. And I based this off of just some of the tutorials, the same ones we walk you through. I decided, you know what, I want this thing actually centered at this location here. So if I go ahead and load, actually, let's see if we have the same one here. Oh, you know, I cheated. So map 1 was supposed to be Palo Alto, California, which is the default one that Google gives you. Map 2 was supposed to make things more interesting by showing you Cambridge, Massachusetts by default. Turns out both do the same. So let's go ahead to map 3.html, which takes things up a notch. So in map3.html, I went through the documentation for Google's API, and I realized, oh, they have some methods I can call to add some neat tricks. One of those methods is the result of adding a control to the page. So what did I do here? I declared a variable called type control. I then instantiated an object of gmap type control. So this is something else Google wrote. And then I added to the map this variable, this type control. So here's another instance of this notion of object-oriented programming. Map here is an object. It's a chunk of memory that has properties and methods associated with it. Well, one of the methods, functions associated with it is called add control, and it in turn takes a reference to, a pointer to, so to speak, whatever it is you want to insert into the page. I'm doing the same thing here, but you know what? I don't actually need this local variable, right? Because this is sort of this is just a find and replace thing. If I'm instantiating this object here, assigning it to a variable, but then immediately using that variable, I might as well just copy and paste the call to new and then this function, this constructor as it's called, and there's a little more on this in this week's section notes. You know what? I can just do this in one line. So I do that with this second control just to illustrate. And then I kind of like some fancy features. I can't demonstrate it on a laptop here, but if you have one of those mice that has a scroll wheel on it, if you've ever used that with the real Google Maps, you can scroll in and out with that thing All it takes is one method call to enable that, and another method call to make the scrolling smooth so that it's not a big change all at once, but it's kind of a nice animation to the end. So let's take a look at this. This is map3.html. And in fact, I have now a full screen map. So I did some XHTML trickery, but now I have this familiar thing on the left-hand side, which lets you zoom. That was not there a moment ago. I also have this hybrid thing here and the satellite thing, things you're familiar with. But the point is that all it took to add these to your page were some additional method calls. Now, where do you find out such details like this? Well, in the case of Google Maps, you read about it here. Maybe we walked you through this in the spec. Maybe you just did a Control F and looked for something like control and found, oh, so here's a discussion of controls. Here are all of the controls that Google Maps apparently supports. And it's not interesting for our purposes today, all the little features of this thing, but just how you can figure out what they actually are. But the best resource, the php.net, or the man page for this API is what I showed last week, which is that this is all of the functionality exposed by Google Maps. And searching this thing with Control F or the search bar up top will become your best friend while implementing problem set 8. So what else can we do? Let's see in map, let's see, 4. So map 4, I decided to finally make something more useful. And I decided to plant a marker in the middle of the page. So I figured out the latitude and longitude of Cambridge via Googling around for it. You can find these kinds of things in any number of ways. I planted a marker probably just by calling a function that does this for me. And in fact, if I scroll down, this is in map4.html. I'm scrolling fast because it's all the same stuff as before. Notice that, here we go. Let's see. I first did what? I apparently created a point, so to speak, a Google latitude longitudinal point at 42.this, comma, -71 that. So I figured that out by some other means. I then centered the map on that point by calling the method setCenter, which I just figured out from the documentation. Now I apparently am instantiating a new marker, aka G marker, and I'm adding that marker to the overlay. So I'm telling this marker that it belongs at this point. I'm adding this overlay as though you're putting transparency on top of transparency on transparency on top of this map. And those transparencies happen to have markers. So in this case, these little red icons. But now there's something interesting. It's not complicated, but it's a new or neat trick. So you may recall from our days with Scratch in week 0, there was that notion of events. You could broadcast an event, and then you could wait for events. You could listen for events, so to speak. JavaScript is very event-oriented, as is most software that interacts with users. Users don't necessarily follow a very linear or serial approach when using software. They might click up here and do something. They might go over here, here. They don't follow a specific set of steps because you have so many menu options and icons available to them usually. So with JavaScript, it really captures this idea by letting you register functions that will be called when the user does something of interest. So you don't sit there in a while loop constantly waiting for something. Instead, you tell the browser, get back to me proactively when the user has done this. Now, what am I interested in? Well, I'm apparently calling a method called addListener. This is something in the gEvent library or in the gEvent object. Now, what am I listening for? Well, I'm adding a listener to the marker. So marker in this case is the variable I created here. You can think of this as a pointer or a reference more generally. Now, I'm listening on this marker for what event? The click event. And there's a whole bunch of events. The click event, the drag event, the zoom event, these kinds of user interfaces. Now, what am I going to do when this marker is clicked? Well, here's one of those Lambda functions. Go ahead and invoke the following code. Now, I didn't give it a name because I don't really need to, because it only exists in order to handle this event. Well, apparently all I'm doing is this. Prepare some XHTML. Boldface the word Science Center, a couple line breaks, have a link apparently to Wikipedia, and that's it. And then the last thing I do is call the map objects open info window method at this point, plugging in this XHTML. So what is about to happen is when I click on this marker, a gInfo window pops up, gets populated with some XHTML, And that's in fact exactly what happens. So what you're hopefully inferring from these examples, that these are little hints as to, these are little building blocks that simply need to be mashed together in problem set 8 in order to create what is the same idea, but certainly more sophisticated in that the thing drags around. You can search for other zip codes altogether. We can go back to 02138 and get whisked away to Cambridge. Some new news gets listed here. But it's the same idea. So create a marker at this point, put some XHTML into theginfo window, and then display it, and so forth. Well, what else can we do? That was map 4. In map 5.html, I'm doing one last thing, which is going to sort of tie everything together here. So map 5.html now looks like this. So same kind of map embedded in the page. But when I actually click this, I embedded this marker in Google's Palo Alto office, so at the coordinates of Google's office. But I decided, you know what, I don't want to just hard code some link like I did for Wikipedia. Let's have some dynamism here. Let's try to tie together the idea from problem set 8 of dynamically grabbing news articles and plugging them into these little cartoon bubbles. But I'm going to keep my domain the same. Let me actually grab from Yahoo a stock quote, put it inside of the info window, and then show it to the user. So this is all happening pretty quickly, but the moment I click this marker, I'm actually getting a current price. See, it did in fact change. So it's slightly different now. So how am I doing this? Well, this is map5.html. If I go ahead and scroll down here, it's almost all the same. Here's the GLAT longitude for Google's Palo Alto office. What am I doing? Well, I'm adding a marker right at that point, and then here's the info window now. So most of this is just some XHTML. I'm going to add a listener to that marker, waiting for a click, and when it happens, browser should call this function here, another Lambda function that I've inlined. But the only fundamental difference now is that rather than do some preordained task of spitting out like that Wikipedia link, now there's some dynamism because the following lines of code actually tie together our discussion of the Ajax stuff into this mashup context so that when you actually click that marker, the browser goes out, asks Yahoo by way of my quotes3.php file for the latest stock quote for Google, returns that as the same XML we were using a few minutes ago, grabs the Google price, and embeds that in the info window instead of, say, the Wikipedia URL. Now, it turns out there was this nuisance, recall, when we were doing all of our Ajax stuff where you had to do this try, catch, and in fact, if you really want to support all different types of browsers, there's even more stuff you should really add to be as cross-browser as possible. Well, this is a pain in the neck. I mean, every one of our examples thus far has had all of this junk just to tolerate incompatibilities across browsers. So much nicer is it when someone else does that work for you. So one of the things Google gives you, and a whole bunch of libraries exist on the internet for this stuff, is an Ajax library. They call their library the GXML HTTP factory. And what you do quite simply is if you want to make an Ajax call, you use this one line of code, and this will figure out how to create that XML HTTP object that we talked about last week. You don't have to care about it. It will just give you the right one. Then you go ahead and call request.open, using a get method. I hard-coded this because I always want to get Google. There's no user input here for this example. I hard-coded in symbols equals goog for quote3.php. And now I registered this function, this Lambda function, to handle that. So now we see this convergence of our two examples today. So if this is a successful call, ready states 4, request.status is 200, prepare the following XHTML. Boldface the word Google, put a couple line breaks, then declare a variable called quote, which, if I keep this on one line, go into the DOM, response.xml, the tree, get the elements by tag name, get the quote, and get the 0th one, because I know I only got back one quote for Google. Then go from that quote, that node in the tree, call its getElementsByTagName method, get its price child, and you know there's only one of these, because again, I prefabbed the XML that's getting spit out, get the 0th one, go ahead and get its first child, which you know to be the actual price node, and go ahead and get its value. So there's a lot of sort of steps here, but you'll find that these are just sort of hoops you have to jump through, copy-pastes that you need to do in order to recreate this kind of functionality. Because once I have that price, I can then append it to a $sign and then call, just like that last example, this method, open info window HTML. On that point, with that XHTML. And the end result, if I click it now, is going to be Google's latest stock price, which is yet again ever so slightly different. And I can click and drag this map just as before, but there's now Ajax going on. And to be clear, if I pull up my little sniffer, click clear, click this thing here, you'll see that in fact there was an HTTP call that went across the wire for quote3.php. There's one thing I should point out here too, and I pulled this up earlier. When I went to my Tools menu and went to JavaScript Debugger, this is one of the things we recommend in the course's spec for problem set 8. So right now, you get an interface that you probably won't need to use all of. Think of this as a nice sort of JavaScript version of GDB. It's a debugger, but it's wonderfully useful because back in the day, if you're using, say, Internet Explorer, the only means by which IE tells you that there's a bug in JavaScript code is to put a little yellow broken icon in the bottom left-hand corner of your browser. And if you click that, you usually get a very unhelpful error message. This thing, by contrast, for Firefox, doesn't mean you have to use Firefox all the time, but for developing it's useful. If you go ahead and make some stupid mistake like, let me leave off, let me see what happens if I leave off this parenthesis. I'm not sure how bad this will be. Now let me go ahead and reload the page because I need to re-download the JavaScript to the page. Okay, that's just bad, right? But where do you even begin debugging this now, right? Because you can't really step through it, it seems, very easily. Now if I go back to, what happened here? If I go back to my debugger and actually reload this thing, of course, one time I do, I'm going to start mumbling to myself again for a moment. Map 5. Let's go ahead and what can I definitely break here? Remove a couple of those. Okay, that fixed it, apparently. Hang on one sec. Let me go ahead. I'm going to call a function that doesn't exist, DD listener. Let's see if I can break it now. Damn it. Wow, okay. Okay. When you're at home doing this before lecture, this should show you in this little interactive session window some kind of informative message as to what the error is. Frankly, David is perplexed right now as to why this is not working when it actually should. Let me try one last thing. How about we get rid of this? That's really bad. Let's see. Okay. How did you begin debugging something like this? Post to the course's bulletin board when you get an error, and one of the staff will help you through these things. So that thing does work. I don't know why it's not working at the moment. But install it nonetheless. Do as we say, not as we are doing, and you'll find that to be quite helpful. So questions on our JavaScript stuff? Questions at all? Sorry that demo failed. Yeah? This here? Down here? Yes, yes. So to summarize, getElementsByTagName does look not just at children, but all of the descendants of a particular node. So because I hard-coded in one stock symbol, Google here, I could have made sort of a leap of faith and said, don't even get the quote element, just get the price element, and it would have in fact worked. But I was just mirroring the approach from last time. Can you pull... Oh, yes, absolutely. So you can stagger these things. I'm simply using local variables here to sort of be more clear and take things step by step, but absolutely, you could cascade it with just more dot, 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 dot. What you have to realize, though, is that I'm being a little dangerous here, because if my code receives a malformed XML fragment for some reason, and there's no price element or there's no quote element, this dereferencing of the array with bracket 0 will actually trigger a JavaScript runtime error, and things will break. So in fact, I should really be checking a whole lot more variables here for null. But we have been doing this in very rapid form, and so we're trying to keep our focus on the interesting parts, not on the rigorous error checking this time around. But good question. OK. So we took for granted for many months' time now what's actually going on underneath the hood. We assume that there is a compiler like GCC that we have access to. We've now been assuming there's a PHP interpreter. We've now been assuming there's a JavaScript interpreter. But how are all of these things actually working? The goal of these last few minutes in class today is to give you a taste of what's been going on underneath the hood this whole time, and also where you can begin to sort of dig for other opportunities for performance enhancements, for design decisions, functions, and it's in the hardware and the interface between hardware and software that is sort of a typical next step in computer science, ergo CS51 and 61. So when we say that you are compiling your program, particularly in the context of C, which is the only compiled language we've looked at or used in any, to any extent, there's actually at least 5 steps there. There's this notion of pre-processing, where GCC or part of GCC goes through your code and looks for all those sharp symbols, the includes, the defines, all of that stuff that gets substituted out with a la copy-paste. That's done in the pre-processing step. Then there's this notion of compiling, and what compiling really means, in at least the context of C, is taking your source code and outputting what's called assembly language, which is not quite zeros and ones, but it's pretty close, but it's still human readable. It's the assembly code that is then, quote unquote, assembled into zeros and ones, and those zeros and ones are then, quote unquote, linked against other people's zeros and ones. Anytime you've used the standard stdlib, stdio, or any number of other libraries that you were sharp including in your files, by way of their header files, well, what you're really doing is telling GCC to compile your stuff, compile their stuff, if not already, and then at the very end of the compilation process, link their bits with yours and merge them into one .exe file, one executable. And then running software, of course, is a matter of running those bits. Well, just to give you a sense of what this stuff might look like, we have here a snippet of source code, and you have printouts of both of these since it's small on the slide. But the top one is some baby program, hello.c. It's our typical hello world program. What I did was I ran that what is that, like 6 or so line program through GCC with the $S flag, which outputs not object code per se, but assembly code. So it shows me the intermediate step that GCC is taking. Literally, what that outputs is what's in this second box here, called assembly code. And in fact, it does look very similar to it still looks human readable, but it's still a little cryptic. We have words like sub and add and move and. So it does hint at what's going on here. But what you're really seeing are the most basic primitive operations that a CPU understands. So GCC is a compiler that was designed on the cloud for an x86 architecture. So the cloud that we're using, our web server, these are all typical PC hardware. So they're running Intel CPUs, x86 CPUs, and what it means to be a CPU, recall, is that you understand a certain set of instructions, an add instruction, a subtract instruction, and so forth. And it's out of those trivial, basic building blocks that you've seen over the course of the semester, you can clearly do some interesting things. So hello world literally becomes that in machine language, so to speak. This is the x86 implementation of hello world that I wrote in C that GCC then transformed into assembly code so that these instructions could then be fed to a CPU. Now, they can't quite be fed yet. They still need to be massaged into zeros and ones so that they follow a certain pattern. Plus, notice that, or recall that printf is a function that hello world obviously calls. And notice this line of code here. Similarly, can assembly code invoke other functions, system calls. And what it's doing here is it's calling printf, which is a function that presumably someone else wrote. So this isn't all of hello world, because apparently we need to now link in eventually whatever code someone else wrote to implement printf. And so that's where this process of linking comes in. So if we have hello world here and it uses printf, well, yes, we go ahead and compile it. That outputs a file called hello.s, or really it just ends up in RAM temporarily, or on disk if that's how the program is designed. But that assembly code is then immediately transformed into zeros and ones, at least so far as we can tell. So step 1 is compilation. Step 2 is assembly. But had we used some sharp symbols and that kind of stuff, which actually we did for standard I/O, we would also have this pre-processing step as well. But there's one thing that needs to be done here. Because I'm using printf, someone else's function, I need to, quote unquote, link in someone else's bits. So simultaneously, in effect, is this right-hand side of the picture happening. So just as my code's getting compiled, so is standard I/O's library. So remember that I sharp included that by way of sharp include standardio.h, which is up here in the top left corner of this diagram. Now, that's just the header file that corresponds to a .c file that someone else wrote some number of decades ago. Well, standardio.c is where printf is actually implemented. So sort of in parallel is GCC, or simultaneously compiling that file, unbeknownst to you, standardio.c. It gets compiled down into assembly code, looking with all those x86 instructions. And then those instructions finally get assembled into zeros and ones. And then what GCC does at the very last step is link the two together into just one executable file. So many of you, over the course of the semester, when we looked at C, got errors like undefined symbol because you had forgotten to do -lm or -lcrypt or -lcs50 when compiling. Well, that's because this very last step was breaking. You, by failing to include -lm or -lcrypt or -lcs50, you were failing to tell GCC that there's a whole other half of the world that needs to be merged with your code. And so when GCC saw functions like getInt and getString and the round function in your own code, those bits were not actually inside your binary. They were somewhere else in someone else's library code. But by failing to tell GCC where those are, in what library, it just freaked out and decided, this is not a symbol I recognize. You need to tell me what it is. But in fact, it's this picture that was happening all this time. Now, in reality, it would be pretty stupid if GCC were constantly recompiling standardio.c again and again and again. So in fact, all of these kinds of standard libraries are precompiled into what are called shared libraries or dynamically linked libraries, DLLs in the world of Windows. So it's done once for obvious efficiency reasons. But it is linked in again and again. Now, why is all of this useful, or what actually happens when you have these zeros and ones? Well, the simplest computer to think about is perhaps a calculator. A calculator is capable of very simple arithmetic, much like an x86 computer is, but a calculator's instruction set, the operations it supports, are certainly far more limited. You can only do so much on a cheap little calculator. But inside of a calculator are the same principles, the same types of hardware conceptually as in a bigger, faster computer. Inside of a calculator, we can say there are these things called registers. And we did talk about these briefly earlier in the term. A register is like the tiniest unit of memory that exists inside of a CPU. So RAM you have a whole bunch of, but CPUs only have maybe 32, 64, some relatively low number of registers, but it's only on registers that CPUs ultimately do their thing. When you say add x plus y, that means x got loaded into one of these tiny registers, y got loaded into one of these tiny registers, the sum got computed, and the result went into a third register altogether. And so that's what this picture here is hinting at. On a calculator, you type in the number 2. The 2 is temporarily stored in a register. You hit the plus, somehow the calculator is remembering that the instruction it needs to execute is the add operation. You then type in the number 3. The 3 gets stored in a second register. You hit equals, and the sum, 5, ends up in the third register. And that's precisely what happens in a full-fledged computer. Or in this case, the example, 1 plus 1 equals 2, which I kept it simple, apparently. So what, in fact, is inside of a computer? Like, how do you sort of tie all of this stuff together? Well, this list here, this laundry list, just hints at the kinds of things that one can talk about in computer science classes that are talked about in things like 61, 141, and higher level classes still. But you have these things called registers, the tiniest pieces of memory on which computers actually compute values. This notion of a program counter, which is like the computer equivalent of the variable I, which just keeps track of where in a program you are currently executing, because programs are all about jumping to different spots thanks to conditions and loops. You have memory, aka RAM. You have control units, which is a lower level of detail than we'll go into in this course, but it combined with the data path is what actually allows you to do arithmetic in computers. And then you have I/O devices, these things like printers and monitors that actually talk to the human. Inside of the CPU itself, you'll see in classes like 141 that there's this thing called control, data file, and data path. But I think more interesting is to focus for just a moment on what is a specific CPU is capable of. So what we saw a moment ago is this. If I execute this make file, which quite simply has this line of code, so gcc-s-c of hello.c, that gives me this file, hello.s. So apparently we can infer from this what's going on inside this program. Apparently there's this section, so to speak, and we've used that jargon before, and this is the .ro data section. What might ro data mean? What's that? Not readout, but read-only. So read-only data, because this string is not going to change throughout the life of this particular program. What string in question is it? Well, it's the hello world string, and that's in, then comes the so-called text segment. Well, we've used this jargon before when we said that inside of a program's memory space is not only its heap and its stack, but also its actual bits, the zeros and ones that comprise the executable, the text segment. That is here. Well, what is here? That's this stuff. So we spent earlier in the term talking about memory. Now we're sort of looking at the executable file, and this is printf. And we won't walk through this in this class, but in something like CS61, would you actually understand how this is actually happening? And in fact, some of these % symbols here are actually referring to what are called stack pointers. An actual memory address is on the pointer, and it's in this low-level magic that those things like buffer overflow exploits become possible when you understand that. So what can a CPU like an x86 do? Operations like this, but just to put this into perspective, and to give you a sense of just how much a computer can do per unit of time, most of you have 1 gigahertz CPUs these days, 2 gigahertz CPUs, a lot of them dual core, so you have like 4 gigahertz of power available to you, 4 billion operations per second. Well, what this table is hinting at, and the particulars aren't so important today, is that this is how many cycles, how many tolls of the bell it took very old PCs, called 286s, 386s, 486s. If you ever saw one of those retro computers that just had like a green and black monochrome screen that didn't really do all that much, that was a 286 or a 386 or a 486. This is the precursors of the Pentiums. But just look, even back then, it took, for instance, only to add one register to another, as implied by this first row here, reg, comma, reg. It took only 2 clock cycles on the earliest of PCs, 1 clock cycle on a few years later's hardware. And what that means is, again, if your CPU contains a little crystal that's oscillating at 4 billion times per second or 2 billion times per second, it only takes 1 or 2 such clicks just to add 2 numbers together. And it's out of those basic principles like addition that all of the stuff we've been talking about this class actually happens, including this high-level fancy stuff of Ajax. So we'll leave you with that. Have a good Thanksgiving, and we'll see you on Monday.